Hello everyone. In this video today we're going to talk about queues and dequeues. Now I already created a video about the stacks and today it's the queue turn. Now the queue follow the principle of first in first out, and it's a principle that we use in our daily basis every time you go to order food from a drive-through, or you go to the grocery store to pay for whatever you buy there. So the concept, we use that in our daily life. Now, in data structures, also we do have queues and that could be used for many different types of applications. And the ideas are very simple: first in, first out, and that's what queue is all about. Here we got some examples to show you how a queue would look like, and basically, depending on what type of data structures you're using to build a queue, could be a linked list, it could be could be a vector, but you're going to start adding elements from the back of that data structure or from the end of that data structures, and you remove elements from the front of that data structure. So unlike the stack where you add elements and you remove elements from the end of it, which makes it a little bit easy, we instead in queues we actually add the elements from the end and we remove the elements from the beginning. Now this process by itself may lead to some complications when it comes to the implementation, especially if you're using a vector. I'm going to show you some examples maybe later of where's that difficulties are coming from, but in general this is basically how it works. So here we go. This is just to demonstrate the concept of queues and how does it work. So you can see here how those elements are added to that queue. Here's one of the applications we use. For example, if you have a shared printer, we can have multiple people send orders to that shared printer to print documents. And again, the concept that's going to be used here is first in, first out. Okay. So this is when it comes to the concept by itself. Now, how is it implemented using the STL, standard template library? Well, the idea is very simple. Just like the stack, we have a group of functions that we have to consider. Number one, we have to include the queue header file if you want to use it. And then you have this list of functions. We have a function to check if a queue is empty. You have a function that will return the first element in that queue. Then you have a function called pop that's going to remove the first element. And then we have a function called push that's going to add an element to the end. And finally, we have a function that's called size. And size is going to return how many elements you have in that vector. Now, I do have the implementation of a queue here. So you can see here that I'm including the header file queue here, and then in this area here, this is me since it's STL, so it's a template. I'm creating a queue of a type integer. I called it my queue, and I'm pushing those elements into that queue. So I push 3, and then I push after that 2 and 5 and 1 and 9 and then 4. So the first element now in this queue is going to be 3, and the last element is going to be 4. After running this section of the code, you can check the size. You can check the front, which is going to be 3. You can check the back, just going to return what is the value you have at the back in the end. And then pop is going to remove the front. So 3 is going to be out, and now 2 is going to be the front after that. And then I have this function, this for loop here, that's going to actually show you the front and pop it, show me the front, pop it. This is just to show the elements that I have in that queue after all this implementation for these instructions. And then after that, I will check if it's empty, and of course it's going to be empty at this point. Let me comment the dequeue section here so I don't see the results of that. One second. Okay, I'm just going to run it real quick. Oops, what is he complaining about? Oh, look at all these errors. Maybe I think I know what's going on here. This is main 1. This is main 2, so he should not be complaining about this. And none of those has to do anything with the file that we have. It's about the compiling of this project. Maybe he doesn't like the fact that I have multiple functions here. Here's what I'm going to do. Let me change this to be something like this, and this one to be something like this. Let's see if he's going to like it now. Oops, not at all. Well, let me just create a new one really quick. And create a new project. Oops, no, back. Create. CPP file. And now let me go back here to this project. I'm going to copy everything here. Put it here. And let's try to build this now. Nope. Okay, I guess that's what we have here. So let me just go ahead here. You can see here the size. I have 6 elements. The front one is 3. The end is 4. And then after that I popped, so I removed 3. So show me what is the front after that is going to be 2. And after that, show me the elements. So it's 2, 5, 1, 9, 4. And now when I check this empty, it's yes, true. So 1 is returned. Okay, so this is again how do we use STL for queue. Of course, later I'm going to show you how do we use STL with DQ. Again, this is just to show you the implementation of that. In this part, we do have an example about how do you maintain a queue of customers. The file is going to be uploaded so you can have a look at it and see. It's basically how do you think about queues. This could be very helpful when it comes to the project time to give you a guide about how do you create those type of projects. And the class that you're going to create basically is going to be a menu there, and then the menu will help you to insert a new customer in a line, display the customer who next in line, remove a customer who is next in line, and display the length of the line. So this is basically what you need to do. So you can create a class to get all this done easily. Problems with the input, the operation to be performed, the name of the customers if needed. Well, you can create a class for customers if that's what you want. Problem outputs, the effect of each operation. Okay. The design, this is the name of the class that you're going to create, and this is the algorithm. And this is the project. You can have a look at it later. You have a switch cases for the menus. And actually, he didn't even need to create a class. He just go ahead and create a queue, and he called it customer lines. Anyway, it's a really straightforward project. You can have a look at it and understand what it is. Now, before I jump into the DQ, let's go ahead and talk about the implementation of a queue. To implement a queue, we have 2 ways to do that. We can use Victor and we can use lists. The problem that you have to understand when it comes to queues, let me just use the paint for this. Where is it? Did I open a paint? No, I didn't. Okay. So imagine that you are going to create a queue, and let's say the queue that you created is a Victor, and then the Victor you created, let's say, has 5 values. 1, 2, 3, 4, 5. Now, imagine you start populating this queue, so I'll put 1, I'll put 2 here, I'll put 3 here, I'll put 4 here, and I put 5 here. Now, if you want to add a new element, this is how it works. You have to check if the queue is full or not. And if it's full, you're just going to have to extend the size of that queue and move all the elements to the new queue with a bigger size so you can start adding new elements. But let's just put that on the side for now. Imagine this is my queue. Imagine I start adding elements. And imagine I start removing elements from this queue. Now, unlike the stack, remember the stack, we said when you start adding elements to a stack, the moment you get to the top of the stack, if the stack is full, you're just going to have to extend the size of it. But you know that all the removing elements, inserting elements is going to be done at the top. But here, for the queue, that's not the case. One sec. So what do I mean by that? Basically, imagine you start removing elements from here and removing elements from here. So this is my queue. After I got it full, I start taking elements out from that queue. Now, if I want to insert a new element, okay, now that new element, you may think it should be extended here. But that's not the case because we do have space that is at the bottom here. So with queues, what do? We use what we call a circular array. And a circular array basically means as you add elements, before you decide to go and extend the size of that queue, you're going to have to check and make sure that you don't have a space at the bottom. Okay? So if the stack is full, that's the only case. Sorry, if the queue is full, that's the only case where you're going to have to extend the size of it. But if there's a space here, whenever it comes to adding a new element, we just basically, by the time you get to the end, this is the last element we have in the queue, you're going to have to go back to the beginning and start adding elements here. Let's add another element here. And then after that, let's start removing elements. So I removed 4 from here, and then I removed 5 from here, and then I start adding more elements. So let's say 8, 9, and let's say we start removing elements. Let's say 6 and 7 were removed. And then we start adding more elements. Let's say 10, and then you're going to go back here and you keep going in that circular process. Now, what do you need to do whenever you use a vector to implement the queue? You need to always monitor the index of the last element you have. So you can call this the back. And you always have to monitor the index of the first element or the front element. And just because it's called front and this one is called back, that doesn't necessarily mean that front should be less than back. Nope. Here in this case, front is, let's say, 0, 1, 2, and back is basically 0. So that's totally okay. So as you remove elements, front is going to be moved to the next element, and as you move more elements, back is going to be moving into that element. And that's how it's done with vectors. Of course, I'm going to show you the implementation of that in a sec. It's not that complicated. It's all built based on the module operator. Now, this issue doesn't exist when it comes to lists, because here's a list. Let's say this is a queue of elements in a list. So we got, for example, 1, 2, and 3. Now we know that this is pointing here and this is pointing here. Now what do we have? We have 2 pointers whenever you want to use a list as what do you call it? As a queue. The head. And this is the tail. Now those 2 pointers are going to be there. So every time you add an element, you're just going to add it to the end. So this is going to be 4, for example, and then you can add another one. This is going to be 5. And now in this case, the tail is going to be this one. Okay? Now, this here is not the problem, because adding an element to a list is the least you have to worry about. The problem is when you want to remove an element, and the idea here is very, very simple. We know that we have a function called begin, and that begin is going to be pointing to the first element here. So all you have to do is to make the second element the begin element. And now this could be removed easily. We know that with the STL we do have functions that can remove and can add elements. The process is not that complicated. It's very, very easy when it comes to the implementation. So we don't have to worry about a circulation when it comes to the list. You add a new node to the end, you remove an element, just make the head point to the right one. Okay, now how do I put this in a piece of code? Let me just go here. I am going to go back to my original project. And I have the implementation of a vector here. So I'm going to copy this. Copy that. And let me go to the second project, which is this one. Control A. Well, I'm going to need this later. It's okay. I'll get back to it. And here it is. So let's go ahead and talk about this. What do we have here? We do have a vector that I created. The vector header file. And here it is. This is the class. I call it my underscore q. And under my underscore q, what do I have? I have a private section here, which is the size going to be a variable, back and front. Front is going to be the index for the first element. Back is going to be the index of the last element. And I created a vector here, and I created another variable called capacity. This is the initial size of that vector. Now, inside the public section, we do have the constructor. Sorry, I forgot about these structures, by the way. So this is the constructor. I got enqueue. Enqueue is another word for push. dequeue is another word for pop. Get front, get back, print the queue. I created a function to do that. I created a function to return the size. I created a function to check if it's empty, and I created a function to get the capacity. Okay, let's go ahead and see the implementations of these methods. Number one, Q. This is the default constructor. You will set the size to 0. There's no elements. Back and front must be set to -1 to indicate that this is an empty stack. Q, sorry. And then the capacity, I set it to 5. You can set it to any value you want. And then here it is. I'm reserving a space for that using that capacity. In this area, I'm going to start adding elements. Now, whenever you want to start adding elements, the first thing we said, you have to check and see if there is a space inside that vector. Inside that vector. So if I found out that the size actually equal the capacity, that basically means there's no space left to add in new elements. So what I'm going to do here, I decided to duplicate the size of the capacity and reserve a new space with the new capacity. Now you have to remember here, reserve by itself is going to copy the content of the first vector to the second vector with the greatest capacity. Once this is done, the vector here is going to push the new data to the back of that. The function here was going to push the data to the back of that vector. And then after that, this is very important. This is where we're going to do the updating. The back is going to equal back plus 1 moduled with the capacity. The process here is very important. Why do we modulate with the capacity? So we can go in that circle process. So it's not just adding the one to the back. Now here it is, size is going to be increased by 1, and of course I have to do the same thing with the front. Sorry, I'm adding an element. I'm not doing anything to the front. But the only thing that I have to do here is whenever you insert an element for the first time, front need to be updated from -1 to be 0. And this is going to be implemented only when you call the function in Q for the first time. Okay, now how do I remove an element? Well, first of all, you have to check if there's an element to remove. So I'm checking if the size equals 0. Now, if that's the case, then you can just print a message that says, well, the queue is empty. Now, if that's not the case, all we have to do here is very important to update the value of front. And here's the update. Front is going to equal front plus 1. Again, this is for the purpose of the circular move in that data structures. And of course, the size will be subtracted by 1. Now, get front, I'm using the subscriber operator to return the first element. Get back, subscriber to get the last element. And this is just a loop to print the values. And here it is. This is how it works. All I'm going to do, create a counter. The counter is going to hold the value of the front. And then after that, as long as the counter, which is a front, I'm not using front because I'm going to change counter, so I don't want to change the value of front here. So as long as counter doesn't equal back, I want you to show me the value for that vector at that counter index. And after that index counter, must be updated again using the same way. You increase counter by 1, but you have to do the module capacity. So you're going to be moving on in that circular move. This while loop will show you all the values except the back, because again, I'm saying here, if it doesn't equal back, as long as it doesn't equal back, and then show it to me. Then after that, show me the counter, because when it's actually going to equal back, I still want to see the last value. The reason again why I'm not using greater than, less than, because again I told you that before. Front and back, they can sometimes back could be less than front and front could be less than back. So that process of greater than, less than would not work here. It has to be not equal. But the only problem that we have here is that I'm going to be able to show all the values except back, and that's why I'm using this single statement here to show that value. Anyway, here we go. Show me size, or return size, check if it's empty or not, and that's it. What do I have here? Those are just methods and implementing them. If I run it, oopsie daisy. What do I do? Oh, my bad. I know what I did. There's no main function. Let me run it. And here we go. You can have a look at it, and it's basically doing what it's supposed to be doing. Okay, so with that being said, now we can move on and talk about the implementation of the queue using a list. Let me copy that. Copy this. Go down and take all of this away. Control V. Of course, I need to change this to be main. And here we go. So let's look at my queue. I call it the same name. Look here, I just have a variable for the size. and I got a list of a type integer. Now we got my queue, enqueue, dequeue, get front, get back, print, size, empty, all this methods that we had, same as the previous example. And look, here it is. It's a little easier, not complicated when it comes to implementation. Create a new queue, size is going to be 0. And then every time you insert new items, all you have to do is increase the size by 1 and push that element to the back of that list. Every time you want to remove an element, just check if there is an element to remove. And if that's the case, subtract the size by 1 and then pop the front. Get front, get back, printing. I'm using iterators here to have access to the beginning of it. And I'm just going to go with the process that I explained before. How do you use iterators with vectors and lists? And this is going to show return the size, check if it's empty, and that's it. You can see it's straightforward, not that of a big deal. Let me run it. And here we go, same exact results. Okay, so this is everything about queues and how does it work. Now we're going to move on and talk about dequeue. What is a dequeue? A dequeue is a combination between a queue and a stack. So, in another word, with a dequeue, you can push elements from the front, you can push elements from the back. You can pop elements from the front, you can pop elements from the back. That's the main operations that you can do with dequeues. But in addition to that, we have a long list of operations, which I am going to show you here. Let me increase the size here. So you can use the subscriber operators to return elements anywhere in that queue. So you can just treat it as any array. You can use the at function to do the same thing. You can insert elements in the middle. You can erase elements from any place in that list. You can remove a group of elements. You can push front, push back, pop front, pop back, return the front, return the back. And you can check the beginning of it. You can check the end of it. And you can swap to dequeues. You can check if it's empty, and you can check the size. Or you can resize it if you want. I'll be honest, I don't know why do they have to do all of that. It's just an array. If you want to go this way, it's just an array after all. So whatever you can do with an array, you can do with this. Or whatever you can do with a vector, you can do with this one. But again, it's part of the STL, and you can do a research and see what is the benefit of having a dequeue to know better. Okay, so the thing that you need to understand about dequeues, even though I said you got all these operations, but mainly the focus whenever you want to use the dequeue is going to be based on push front, push back, pop front, pop back, front, and back. Those are the function that makes it dequeue more than any of the other functions. So the question that we need to understand here, or the thing that we need to understand here, is how does it implement? And before I show you the code of implementation, I just want to show you a picture so you will be able to imagine how does it work. So this part here is showing you what is a dequeue. A dequeue in general, it's an array of pointers. And each pointer is pointing to an array. So you got one array. Let me just copy this graph. Go to Paint. Control V. Let me move it here. Take this away. Okay. So what do we have here? We have this array, this part here. This is an array of pointers. So every element here is a pointer. This pointer is pointing to an array. And as long as you need more pointers, you're going to start adding array points here. This one also works in a circular, just like you have with the regular queue. But again, the concept here is, if you look at it overall as one term, it looks like it's a two-dimension array. You got a group of rows and a group of columns. Now, the whole point here is to understand where's the beginning and where's the end. So this is front and this is back, if you want to think about it this way. front at the beginning is going to be pointing here, of course, when you starting with the first element. But as you move elements, front's going to be moving into this direction. So offset here is going to always point to the first element you have in this block. But here's the thing. Once you get to this element and you take an element out, the whole pointer here is going to be deleted because there's no point to reserve this space anymore. And then the offset is going to be moved to the beginning of the next pointer or block of code here. And this is how it's going to keep going. Keep going, removing elements. Of course, at the same time, as you insert elements, this is how you find out where's the new space that you need to insert an element. That's basically the offset. Whatever the value of the offset, you add the number of items minus 1 to it. And then you modulate with the block size, which is basically, in this case, imagine it's 1, 2, 3, 4, 5, 6, 7. And that basically will tell you what will be the index of the last element and how do you move with that. Okay, so this is again just to explain how does it work. What I do have here, I have, let me try to delete those files if I can. Delete. And delete. Now let's hope this is going to work with no problems. At the bottom here, I do have a DQ that I created. And now let's see if I can run it. Okay, that worked perfectly fine. And those are the values that I just inserted. As you can see here, I can push front. So I'm going to get 10, 20, or actually 20, 10, and then push back, and then push back. And then this is the size is going to be 4. It's going to show me those values from the end all the way to the front. And then it's going to check if it's empty. Of course, it's going to be empty in this case. Let me go back to the PowerPoint just to explain some of the methods that we have here. Where is it? The subscriber operator. How do you have access to the elements? As I said before, we look at the whole concept as a two-dimension array. So the first thing we have to understand here is the index if you're trying to get access to. If that index was greater than the number of items, so you should know that you're passing your limits. Now, if that's not the case, we need to have two variables, one of them to find out the row, and the other one is to find out the column. And those are the two functions that would do that for you. Okay, so the offset plus I, which is the one you're looking for, you divide it, integer division with the block size. That will tell you which row you will find the data you're looking for depending on I. And if you want to find the column, of course, you're going to have to do the same thing, but this time it's going to be modulating the block of the size, and then return it in this form. It's going to look like a two-dimension array, as you can see here. What else do we have here? How do you add an element to the end of this DQ? Well, first of all, you're going to have to check the capacity, if there's a space for it. So the capacity you're going to calculate is going to be basically the data size that you have plus the block multiplied by the block size. And then if the new item, let's see, what is the new items here? We got the item here. Number of items plus the offset equal the capacity. That basically means you can just push it with no problems. Yep. And then after that, you're going to have to increase the number of items by 1. And then you're going to have to, let's see here. This is supposed to do what? Pushback. So update it. Here it is. Now, the last part is how do you remove the front? Well, what are we going to do basically, since you're taking an element out, so you're going to have the offset is going to be increased by 1, and then the new offset, if it does equal the block size, that basically means you got to the end of it. So we're going to have to delete the whole front, the whole line, and then you're going to have to pop front the data, and the offset is going to be set to 0, and of course the number of items is going to be subtracted by 1. So this is what Qs and DQs is all about. It's not a complicated concept. It's really easy. And thank you for watching.